Assalamu alaikum. Welcome back to School of Physics. Understand Universe. Welcome to another class. And in this class, we will discuss further about the, as our discussion is already going on about the Newton's laws of motion. So here in this class, I will deal with the another motion law, which is the second law and the third law. But before that, to understand the second law of motion, we have to understand first before that the momentum. So in this class I will talk about the momentum. I will write down it first. Momentum. Because this is a very much important topic as far as the classical mechanics is concerned. So what does momentum actually mean and how it is, how much useful it is in the classical mechanics? We will try to get on to that. We'll try to understand this very concept. So first and foremost, momentum is defined as the product of mass of a body and its velocity. That means the product of mass with its velocity of a body, with its velocity, the combination of these two, that is the product of mass and velocity, these form a term called as the momentum. Although we can't see directly momentum of a body, directly seen or observable by our eyes, it's a concept. It is the product of these two. As we can say, mass of a body is observable thing. This very object possesses a mass. We can measure that directly because it's a fundamental thing. It's a fundamental physical quantity. Okay, but in the classical mechanics I am talking about. In the advanced physics, that is some different story. So, but momentum is its mass times what velocity does it possess. So, momentum, which is represented as P is denoted by, momentum is denoted by P. So, P is equal to mass of the body. Say we represent it by m, mass of body, and its velocity multiplied by velocity of the body. Suppose this is our body possessing with mass m and with the velocity v, it is moving in this direction. So its momentum will be defined as the product of this mass and its velocity which it possesses. Okay. And also another thing, this is a vector quantity. This is a vector quantity. And you might be well aware about vector quantities. Vector quantity is that very quantity, that very physical quantity, which all we can say, we know that it can be measured, but it possesses a specific direction as well. And here in case of the momentum, the direction is as that of the velocity. So whatever the velocity is, same is the direction. The direction of the velocity is the direction of the momentum of that body. So for example, in this case, suppose this is the z direction, z axis. So the component of velocity, all of its components, although, are along the axis z. Okay, so the direction of the velocity is z. Similarly, P, direction of momentum, will be also that of the velocity, that is the z direction. So that means P is a vector quantity and its direction is given by the velocity possessed by the body. So whatever will be the whatever will be the velocity heading towards, same with the direction for this momentum. So in short, this is a simple definition for momentum. Momentum defined as the product of the mass with its velocity. Now, take the examples in our day-to-day life. There are many examples. For example, different bodies possess different momentum in what situations, in what conditions. For example, take two bodies. One is lightweight body, that's lightweight. Say for example, vehicle, some bus, car, suppose lightweight vehicle, and heavy weighted, okay, heavy weighted, possessed heavyweight vehicle. For example, it is a small car and this is a bigger bus. These are the two examples. So we know, suppose this is the M1 mass possessing, this is the mass possessed by this very vehicle is M2, and we know M2 is greater than M1 because M2 is the bigger bus with more mass than the smaller vehicle. So M2 is greater than M1, and we know that if this body is set in motion, suppose it is set in motion, and we want this body, we want it to be stopped, okay? But to stop it, to stop this vehicle, we need a force, because from the first law of motion, we know that every body possesses inertia, okay? So it will try to remain in its motion, but if we want to stop it, okay, for that we have to apply force. But if the two cases are there, one is smaller mass and there is bigger mass, we have to exert some force to stop this very vehicle also, to stop this very vehicle also. But the force will be different. In this case, force applied will be smaller, okay? But in this case, we need more force. Because it's a common observation. I'm not doing any mathematical calculation right now. I'm just giving the common observations, examples of common observations which you might have also seen in your day-to-day life. So, for a bigger mass, you need more force. For a smaller mass, you need less force. So what does that mean? That means we can say that the force required for the smaller mass is more, so it possesses more momentum. This one possesses less momentum as compared to this. This possesses more momentum. So actually force is indirect calculation of momentum, or momentum is indirect calculation for force. That means if we know one quantity, we can say that the force is proportional to that, okay? More the force to apply for stopping this car, we need, that means this car possesses more momentum. Similarly, if this car possesses less momentum, that means we need to stop it with lesser force. We can stop it with lesser force.